answer to these questions. So where the energy coming from in a chemical reaction? When a metal and oxygen combines, we see the light and then heat that gets generated. Where that energy coming from? And then in some species live in a sulfur mines. That's very hot environments. How those microbes were able to survive in those harsh environments? Do you know answer for this one or about this one? How does the electricity flow in a wire? Does it flow from anode to cathode or cathode to anode? When you look at the um, nucleus of a atom, is it possible to store the energy in a nucleus and retrieve it later? Can we use the nucleus as a battery, as a cell? Um, let's look at the last one first. And then, so this is a series of talks I'm giving. This is the second in the series. What is holding the science from making a big leap forward? The talk is it possible to store the energy in a nucleus and retrieve it later? My name is Karnakar Marsakatla, and today is May 5th, 2024. So when you look at the ionization of an atom, if a neutral atom acquires an electron, then that becomes a negatively charged ion. We know that. So atom releases the energy when it acquires an electron. The amount of energy released will be equal to the ionization energy of that orbit in which the electron was captured. So when you give an atom an electron to the atom, so that releases the, certain amount of energy based on the ionization level energy of that shell in which that electrons was captured. Similarly, if a neutral atom sets an electron, then that becomes a positively charged ion. Atom consumes the energy when it sets an electron. The amount of energy will be required to the ionization energy of that orbit from which the electron was ejected. The same way, if you give enough energy to the topmost electron, so that escapes from the atom, and that energy is equal to the whatever the ionization energy of that particular shell. So we are seeing, certainly we are seeing, we are giving energy to a atom and then taking the energy from an atom in these two scenarios. But where does this energy store inside an atom? So let's look at the let's look at how the nuclear fission works. An heavier nucleus split into lighter nuclei with the release of particles or rays and energy. So those are the byproducts. When you split a heavier nuclei into smaller nuclei, either some particles or some rays gets released along with some energy. And then, so when you look at what is actually happening to the nucleus, so we are splitting the nucleus. Splitting a nucleus releases the energy. So what is mean by splitting the nucleus? It means like we are basically separating the nucleons within that nucleus, and that releases the energy. So separation of nucleons could be within the same nucleus. That's so when the nucleons are separating, that's what releasing the energy. So the separation need not be necessarily as part of two different elements. So the separation between the nucleons could be within the nucleus itself. So even a smallest bit of increase in the radius of the densely packed nucleus will also release the energy. That's what I'm theorizing. So let's look at this as a picturization. So this left is the densely packed nucleus, a neutral nucleus, and the center ones are neutrons, and then outer ones are protons. This is all nucleus. And then when this expands a bit, like where these particles separate themselves from each other. So this is an increase in the radius of the nucleus. So when that happens, that should release the energy. If the fission concept of fission is correct, this also should release the energy. So this is a boron nucleus, neutron boron nucleus. It has 5 electrons in the shell, like one in 1s2, and then 2s2, and then 2p1. And then this is a negatively charged boron atom, where we are adding another electron to the top shell. So what happens in this case? So negative ionization of an atom is a small scale nuclear fission. So when you add a electron to a atom, so how do you physically represent that scenario? It's releasing energy, right? So neutral atom is like this, and then this has P1, and then P2, we are adding an electron to that one. So when you add an electron, it releases certain amount of energy equal to the ionization level of that shell. So we are extracting energy out of that atom, and then what kind of physical change that undergoes. So what happens is when we have electrons shells around this atom, when there are more electrons, like now we have 6 electrons here, and then we have only 5 protons. So the pull, so basically the neutrons, nobody knows how the nucleus actually looks like, but I am theorizing that at the center there will be possibly neutrons, and the outer circle has protons, and then again in the outer circle electrons. So when there are more electrons in the around the orbits, and then these are 5 new protons and these are 6 neutrons, the strength between these two is more, so they pull outward. So when that makes the nucleus to expand, and then so that's what happens. So um, that makes it to release the energy, because there is a fission is happening at a very small scale. Negative ionization of an atom is a small scale nuclear fission. So similarly, when you look at the nuclear fusion, if there are right conditions, all the byproducts of the fission, including the energy that was released, can be combined to form the original heavier nucleus. Theoretically, if you think like you generated certain byproducts out of some reaction, and when you combine them, all of them, you should get the original product. If you join, so joining a nuclei consumes the energy. If you give the energy back into the system, whatever that nuclei that was split from the original heavier nuclei, so when you join them and give the energy, so that consumes the energy. So joining the nucleons stores the energy. So that's what happens. Bringing the nucleons a bit closer could be in the same nucleus. So when you join the nucleons of different atoms, or bringing the nucleons a bit closer, that stores the energy. So as the radius of the nucleus decreases, the amount of energy it stores will also increase. As the radius, when it becomes radius decreases, that energy, amount of energy it stores will also increase. So let's look at the picturization of this scenario. So this is the neutral atom of the boron. So this one has P1. So we remove the P1, this last electron from this atom. So that becomes electron configuration becomes 1s2 and 2s2. And now what happens is there are less number of electrons circling around this atom, and we have 5 protons and 4 electrons. So that makes the strength this strength towards the nucleus is more than um, that is pulling outward. So that case, these nucleons will pull towards the center, and the radius of the nucleus will decrease. That's what a positive ionization of an atom is, a small scale nuclear fusion. So it's basically nucleons are coming closer when you positively ionize an atom. So this size change, this change in the radius of the nucleus is what actually storing the energy in ionization of the atoms. So nucleus as an energy storage unit. So as an electron gets ejected from a neutral atom, it stores the applied ionization energy by increasing the density of the nucleus. In this case, the radius of the nucleus gets reduced as more and more electrons gets ejected. So if you keep removing the electrons, the nucleus gets compact, and then it stores more energy because the nucleons are more closer to each other. So similarly, as an atom captures an electron, it releases the ionization energy of the orbit in which the electron was captured. As a result, the radius of the nucleus increases compared to its earlier state before capturing the electron. So that's what happens when atom captures the electron. When you look at the nucleus as an energy storage, the continuation of that concept, an atom changing between a negative, neutral, and positive charges works as an energy storage unit. So when you like make it, if a positive ion, so you add an electron, it gives off the energy, and then if you take the electron, it consumes the energy. So status changing between neutral, negative, neutral, and positive. That's what the size of the nucleus keep changing depending on how many electrons are there around the nucleus. Storage and release of energy occurs within the nucleus in the form of increase or decrease in its density. An increase in the density enables the nucleus to store the energy. Similarly, a decrease in the density enables it to release the energy. So density, how do you define? Density inside a nucleus can be defined as the cumulative distance of all nucleons from each other. So that's what, if all the nucleons are closer to each other, it will have more energy. If they expand a bit, if they occupy more space inside the nucleus, then that will have less energy. So this changing, oscillating states of the nucleus is what storing and releasing the energy. So what is the relation between, how could you define the relation between density, energy, and then the concept of deficit in mass? So distance between the water molecules increases as it crystallizes into ice. The energy released in the process is coming from the separated molecules in the ice. So when you look at the water example, when you freeze the water, it crystallizes, but the space it occupies also increases. At the same time, it releases the energy. If you put it in a glass and then put it in a freezer, the expanding energy breaks the glass. So it's releasing energy, right? So that release of energy is same way coming from when the atoms are separated from each other, it is releasing the energy. When the water, in the other way, when you look at it, when water absorbs energy, it turns back into liquid form and increases its cumulative energy. So what is the effect of increase in the cumulative density? What's happening in this scenario? It exerts more gravity to the earth. So when the density increases, the object exerts more gravity to the earth. It means the condensed form of an object measures more mass. The difference in mass or gravity accounts for the stored energy. So because the object increases its gravity towards the Earth, so it measures in today's standards measures more mass. So the difference in that mass or gravity that accounts for the stored energy. So that is what the traditionally we describe the above phenomenon with the principle of E equal to mc square. But this principle is not sufficient to explain the observations because of the flawed definition of mass. So this, why we are missing all these concepts? Because the flawed concept of definition of mass is holding us from actually realizing what is happening inside the nucleus. So the actual thing, how do you describe in these ionization processes, how it is happening and how to link density, energy and density in mass is a denser object weighs more than a loosely packed object with the same amount of material. So denser object, when you compress an object, so that weighs more than a lighter version of that object towards the gravity will be more for the denser object. The difference in gravity that object exerts accounts for the stored energy. So when you compress an object, the energy you apply to that object is stored in that object in the form of density in that object. So that density itself is an indication to that stored energy. A point-size object stores maximum amount of energy when compared to its other variants with the same amount of material. It is also the heaviest form of its variants. That's, if you keep on compressing an object, the dense to the point level size, the density of that object increases enormously, and then all that energy you apply to the object gets stored in that, because all the nucleons and everything merges to singularity. That's where becomes heavier, and then it exerts more gravity, and then it will have more density when you compare to any of its other variants. So this basically goes against the concept of definition of mass. What it says is no matter what the size of the object is, the amount of mass it measures the same, but that's not happening in the reality. So these three principles apply to all the objects irrespective of their size and the material with which they were made of. The objects include nucleus, atoms or molecules, piece of wood, iron bar, star or a planet. Anything, you take it and then compress it, it stores the energy. And then when it expands, it releases the energy. So this fundamental property of the matter was grossly misunderstood in the present practice of physics. So that's what happening. We are not taking the density into consideration when we are looking at the energy factor in all the objects. So when you compress an object, the density increases and it stores more energy and it measures more mass or more gravity towards the earth. When it expands, it density of that object decreases and then it releases the energy. At the same time, it measures less mass or gravity towards the earth. The difference in the mass, whatever that gravity that object exerts in these two states, is what accounts for that the stored energy. So what does this all indicate? Um, the same principle applies to the black hole at the center of the galaxy. its compact size and enormous amount of material inside that object exerts tremendous amount of gravity. So that's what. So we are basically misunderstanding the properties of matter and how it stores the energy and its relation to density. That is causing us to misunderstand the black hole at the center of our Milky Way galaxy, and then attributing its behavior to attributing the planet, that solar systems going around the galaxy to galactic center to imaginary dark matter. So because physicists didn't understand how the matter and then works, they attributed the observations to dark matter. The kind the dark matter, basically they misunderstood the concepts of matter. So the similar behavior of nucleus and an object in storing the energy indicates the force acting at all levels is the same. So when you look at the matter, water and the nucleus, they all working similarly. When density increases, they are storing energy. When the density is less, they are releasing the energy. So all this indicates, this possibly indicates that the gravity and the strong nuclear forces are one and the same. That because that's how I see it. So the nucleus as well as any objects, when they increase the density, they are storing the energy. So because we know that it's a strong nuclear force that's working at the nucleus level, and then we think there's a different force working at the objects called gravity. So that's why we are not able to merge them together. So what I am thinking is they could be both gravity and as well as the strong nuclear force could be the same. So the only we are misunderstanding the basic concepts of matter. So this is all I explained in a book called Gravity from a New Angle in 2009. So from that point onwards, I kept writing different articles. You can look at my another video I made about describing all the documents where I published the locations and everything I gave in that video. So if you try to look at this book on the internet, try to enter this in the double quotes. Otherwise, those sites basically list you something else. They just won't show you the right product. So when you look at, when going back to the first question, where the energy coming from a chemical reaction, we already saw. So basically the transfer of electron from one element to another releases the stored nuclear energy from the receiver of the electron. The amount of released energy is equal to the ionization energy of the orbit. So that's what is happening in chemical reactions. And so when you look at when there's a combustion of hydrogen, there are some vehicles running on hydrogen, right? And then so they combust, they burn the hydrogen to generate energy to run the motor in the vehicle. So what is happening in this case? So two hydrogen atoms share the two electrons with oxygen atom to form H2O in a covalent bond. So when you combustion of hydrogen, this is what happening. Hydrogen and oxygen combines to form water. Because the oxygen atom acquires the electrons, it releases the ionization energy of the top two shells of oxygen atom. So the oxygen is the one actually that releasing the energy. So if we call the fuel as the one that gives the energy, then it is oxygen, not the hydrogen atom. So when you go on to the gas station or petrol station and they're taking a fuel, um, you are basically, that is not fuel. Basically, that hydrogen atoms are mere enablers to extract energy from the oxygen atom. So they are combining with the oxygen around us in air. Mm, this oxygen is the one actually running the motor. This is the one actually giving the energy that moves the vehicle. Not so. If you want fuel, fuel is the oxygen, not the hydrogen. You are buying an enabler to extract the energy. So, so how some species are able to live in the sulfur-rich environments? And the second question we asked in the beginning, the top shell of the sulfur structure is similar to the oxygen atom. It has a PS4. A sulfur atom easily gives off energy if it is able to acquire two free electrons. So if somehow if it acquires free electrons, it releases the energy. So the microbes that live in sulfur-rich environments like mines are actually taking the energy from sulfur by giving it electrons. So that's how I think they are surviving in those environments. Basically, every living being needs energy to survive. So that is each species adapted to extract the energy from environment in different ways. So those species adapted to interact with the sulfur to get the energy for their survival. So how does electricity flow in a wire? So in schools, most of the when you're a child, you might have learned like um, uh, electricity flows from cathode to anode. That's what electrons flow from cathode to anode, right? So that's what they measure as electricity. And like whatever that coulomb, amperage. So the flow of electrons is what everybody assumes as the electricity. But contrary to the widespread belief, the energy in a wire flows from anode to cathode, even though the flow of electrons is from cathode to anode. Positively charged anode releases the stored energy, nuclear energy, when it receives the electron. The released energy propagates in the wire towards the cathode. So that's what I, because anode is positively charged, a group of positively charged atoms. So they, um, when you pass an electron to that positively charged ion, it basically releases, and the nucleus expands and then releases the energy, and then that energy flows from anode to cathode, even though electrons flowing from cathode to anode. So that amount of energy, so we have different batteries, right? So one battery capacity is less, and one, the depending on the material, the capacity battery will be more or less. So the amount of energy stored in a battery depends upon the ionization energy of the displaced electrons in anode. So the whatever that ionization energy, if it is 2s2 or 2p4, whatever that electron shell, the ionization energy of the atom at anode, depending upon that level, that how much of energy that gets stored in a battery depends on that factor. So that explains all those questions. And when you, the way we can summarize is, so physics we consider as the mother of all sciences. Almost all branches of sciences look towards physics community to unravel the mysteries in their field, because physics is kind of you can explain any concept at the fundamental level using the principles of physics. So whatever the observations a biologist has, or anybody else in other branches, basically looks to confirm, looks to physicists to confirm this is the process, or this is what is happening at the core level. But the practice of physics by the academic community is widely diverged from reality. So the way we saw the definition of mass, the storage of energy, how it is released, all these things are totally diverged from the way they are being taught in the universities and colleges. So this divergence led to many observations in physics as well as in other branches of science to be in dark without a satisfactory explanation. So if you are making a so gross mistake, um, mass is one of the fundamental units. If that itself is wrong, what else can stand the scrutiny? So this is why so much disarray, so much of um, unexplained things are just accumulating in many branches of science. We are making observations, but we are not able to explain the phenomena that is happening for the behind that observation, and then just every branch of science become isolated. I become more, because we are growing more and more observations and no way to explain them. So they are becoming islands, individual islands. So we need to bring them all closer to a common explanation based on the theory I presented in this talk and in my book. I think let's all bring life to the sciences and make it more fun to study. So I dedicate this talk to my daughters who gave me strength in all circumstances. My elder daughter Soumya and Sumedha. This is for them. And this talk is part of a series. I gave an introduction and posted on YouTube on April 26. And the first talk was about the gestation and egg laying, what determines the species to adapt to these two different scenarios. I published that also on the same day. And then this is today on the May 5th. I'm posting probably I'm recording on May 5th. I'll post it the same day. So this is the series I am building. So what will be there? First I will post some of my discoveries. I'll post probably a couple of more discoveries, and then I will go back to seeing why this chaos, why it's happening like this, why are we like so much confusion in sciences. I'll see what is actually the root cause of all this confusion. Basically, how we publish the research. So I see the drawbacks in how publishing research is bringing this much chaos in sciences. And then at the end, I propose what could we do? What would be the ideal environment to publish the research papers? And this talk is for everybody. Like if you basically watch this talk, if you never understood some of the scientific concepts, no matter how many times you heard about them, this talk might make them those concepts clear. Just watch it and share it to those people. Watch this if you discover something and don't know how to explain it. So this scenario, many of the discoveries falling in this scenario, their observations are piling up. They don't know how to explain it. And then I think going forward, when you actually look at what exactly might be happening at the core level, that might explain all these unexplained observations. So this talk might give you a clue to those observations. Watch this if you are waiting endlessly for the recognition of your discovery. This talk might help to sharpen your theory. So you might have a theory, and then so there might be some holes to fill in. So this talk might give idea to sharpen your theory. Watch this if your articles were rejected, even if their findings were flawless. It happens to many. You try to publish a journal, they rejects, and then you modify in a different format, send it to somewhere, they reject. So this endless cycle. So this this thing, this talk might help to elaborate your theory and make it more strong. Watch this if your articles were rejected by a mere preprint server. This happens. There are a lot of horror stories, I guess, out there. And just even preprint servers, you need a high-level recommendation to post an article. So that is, if that happens to you, just be proud of the distinction. You are in the elite group. Not sure how many of the articles on that server are going to stand the scrutiny that is ahead. See, definition of mass is wrong. What else could be right? So, a lot of the articles that are out there published in the journals might end up gets revised or thrown away. What's this? If you find sheer joy in learning a new theory that makes sense. So this you are coherently you're pulling in every concept of the matter and then explaining them in one single and one single way. So this definitely, if you find a joy in learning new things, I think this talk is for you. And so share this wherever there are with your all science enthusiasts, particularly with the students in sciences, to make them part of the change. So when you involve yourself with the change at the beginning, you will find how it progresses. So I definitely see the change is coming. And then if you get see involved in the beginning itself, adapters of early change will have more understanding of the concept. That's what I believe. So thank you for watching. Thank you very much.